Have you ever heard whispers of a forgotten planet? One that once existed in our solar system, only to be shattered and scattered into oblivion? Between Mars and Jupiter, in the vast emptiness of space, lies a field of broken remnants, a cosmic graveyard known as the asteroid belt. But what if those rocks aren't just floating debris? What if they are all that's left of a once thriving planet? Let's rewind to the early 19th century. In 1801, an Italian astronomer named Giuseppe Piazzi made a groundbreaking discovery. He spotted a strange object orbiting the Sun between Mars and Jupiter. That object would later be named Ceres, and it was unlike anything previously catalogued. Just a year later, another astronomer, Heinrich Olbers, found a second body, Pallas, following a remarkably similar orbit. By 1807, two more celestial objects, Juno and Vesta, were discovered in that same region of space. It wasn't long before scientists began to piece together a tantalizing theory. These objects weren't just individual rocks. They could be the shattered remains of a planet that once existed between Mars and Jupiter. They even gave it a name, Fyatin, sometimes referred to as Fyatin in older texts. This idea became known as the disruption theory. According to it, a full-fledged planet once orbited peacefully in that region, but was later destroyed either by a violent impact or some internal cosmic catastrophe. So, what could have shattered an entire planet? One theory suggested a collision with a massive space object, perhaps a rogue asteroid or even a star. Another more speculative explanation involved Nemesis, a hypothetical red or brown dwarf star believed by some to be orbiting the Sun on a long elliptical path. If such a star existed and came close enough, its gravitational forces might have torn Fyatin apart. Others proposed that Jupiter, the solar system's behemoth, may have pulled Fyatin in too close, tearing it apart with its immense gravitational pull, just like it does with many comets that cross its path. But over time, the disruption theory fell out of favor. As our telescopes improved and our understanding of planetary formation evolved, a new explanation emerged: the accretion theory. According to this theory, the asteroid belt isn't the aftermath of a planet's destruction. It's the remains of a planet that never formed in the first place. Billions of years ago, the early solar system was a swirling disk of gas, dust, and rock fragments, a protoplanetary disk. In most regions, these fragments gradually clumped together under gravity, forming the planets we know today. But in the space between Mars and Jupiter, something interfered. That something was Jupiter. Jupiter's immense gravitational field prevented the material in that region from coalescing into a planet. Instead, the fragments kept colliding and breaking apart, resulting in the scattered rubble we see today, the asteroid belt. This belt lies between 2.1 and 3.3 astronomical units from the Sun and contains millions of rocky bodies. Yet despite the popular image from sci-fi movies, the belt is mostly empty space. The asteroids are so spread out that a spacecraft could pass through without ever coming close to a collision. Still, the largest four asteroids, Ceres, Vesta, Pallas, and Hygiea, comprise more than half of the belt's total mass. These space rocks are crucial to our understanding of planetary formation, as they hold clues to the early solar system preserved for over 4.5 billion years. Ceres, the largest of them all, is so massive that it's classified as a dwarf planet. It's roughly 940 kilometers in diameter and even shows signs of water ice, raising fascinating questions about the potential for life or prebiotic chemistry in such environments. In 1972, NASA's Pioneer 10 spacecraft was the first to traverse the asteroid belt. At the time, many feared it might be destroyed by the dense field of debris. But to the relief of mission controllers, it passed through unharmed, disproving the sci-fi image of a chaotic obstacle course. Since then, several other probes, including Galileo, Dawn, and Juno, have explored the region, each revealing more about this intriguing slice of space. What's even more fascinating is how these asteroids help us peer back in time. By studying their composition, whether carbonaceous, silicate, or metallic, we can understand the building blocks of planets. Some even carry organic molecules, perhaps the same that seeded life on Earth. But still, the mystery remains. Could it be that the disruption theory holds a grain of truth? That there once was a world called Fyatin, torn apart in a violent cosmic event? Or is the asteroid belt just a planet that almost was? Science is a moving frontier, always reshaping itself with new evidence. For now, both theories linger in scientific lore, each compelling, each echoing with the ghosts of a lost world. And that's just the beginning. Stay tuned for Segment 2, where we dive deeper into the largest asteroids, their role in the evolution of our solar system, and the continuing search for a possible Planet 9 hiding beyond Neptune. If you enjoyed this segment, don't forget to give it a thumbs up and subscribe to Infinity Beyond, your window to the wonders of the cosmos.